Hello guys, welcome to Corporate Finance. I hope you're all doing well, especially in this period of global pandemic. So this semester, I'm gonna teach you the corporate finance, and my name is Hong Wu. And basically, this is a graduate level corporate finance class, and we're gonna introduce you the key concepts in the corporate finance from the perspective of a corporate manager. And it will cover various aspects of corporate finance, and then I'll show you how to um, systematically think about corporate decision making. So, and this syllabus, I'll ask TA to upload to the e-learning system, and also I'm gonna ask the TA to upload all the slides. So basically, before each class, we will upload the slides, and also we will hold a class time. So let me first go through the syllabus and to kind of give you a brief overview of the requirements that you need to meet in order to pass this class. It's not very difficult. It's pretty straightforward, the requirements. So first of all, this is our class time. All right. So and because we still have the coronavirus going on, so what I will do is that I'll do a combination of class video recording and also live session Q&A. So what that means is that the class time it was supposed to be Tuesday 8 8:55 to 9:40 and in the evening time. This is the original time, right? But because many of you haven't returned back to China, to Shanghai, so we cannot. So I decided we do class video recording, right? So that is I record class video each time before each class, and then you go through the class video on the class time, and also you ask me question during the class time. So I understand that for this morning time, it will be difficult for you guys if you live in Europe, right? So just try your best to attend the class on this morning time. If you cannot make it, just tell me beforehand. On the class time, we will just do Q&A, which means if you have question, you can ask me. And also every 2 weeks, and announce you I'm gonna announce the exact schedule for the live Q&A session. Uh, like maybe just couple days afterwards. So I will announce there will be like a live Q&A session that happen on the Zoom every 2 weeks. So I will send you the links or the Zoom meeting information beforehand, and I'll pick this time for the live Q&A because I understand many of you are in Europe, right? So if we pick this evening time, then it will be good for both students in Asia and also students in um, Europe. And of course, also good for students who are in North America, right? So that's what we'll do. And then, I mean, basically the live Q&A session that happens twice or once 2 weeks is basically help me to understand and to understand if you have any question about the class progress, if you have any question about the class, if you have any kind of suggestion for the class content, and also to talk about various topics in the Q&A session. This is kind of the arrangement. That is, class video recording will be done before the class, and then you go through the videos and also, of course, the lecture notes and also the textbook, right, before the class. So on the class time, and then on the class time, we do Q&A in a WeChat group. So the TA should have already organized a WeChat group for you. And moreover, there will be a live Q&A session once 2 weeks, right? To help me understand the basic needs, basic requirement, basic suggestion from you. And office hour is this time, but of course, because you guys are in different time zones, you're very welcome to send me an email beforehand, right? Or to schedule a specific time with me. This is our TA. She is Jia Liu. This is her email address. If you have any question or if you want to send homework, you can send homework to her. And so this is administration. And also next is the assessment. So basically, there are two big parts, right? You do homework. So there will be five sets of homework questions. And then the final exam accounts for 40%, right? And then the final individual report accounts for 20%. Of course, I will announce the requirements for the final individual report during the semester, so you don't have to worry about that now. And for the textbook readings, you should get this textbook, which is Principles of Corporate Finance. Reilly, Mize, and Allen, 12th edition. You don't have to get a paper copy. There are a couple of electronic copies available online, so you can search them. And of course, there will be also lecture notes and the videos that will be uploaded online before each class, right? And if there's additional reading, I will assign you 1 week before each class, right? And because we're gonna talk about corporate finance, this is basically the set of topics we're gonna cover in the class, right? So in topic 1, we're gonna talk about present value and its application, right? Then we talk about how to use the NPV method, net present value method, to value bonds, to value stocks, right? And then we move on to talk about portfolio theory and CAPM. Then we talk about efficient markets and behavioral finance. Then we talk about corporate financing. And then we talk about capital structure. So how much that is optimal, right? How much should a firm borrow? And finally, we talk about mergers, corporate control, and governance, right? So basically, we talk about merger acquisition. Of course, that also include the valuation of merger acquisition, right? And we also talk about corporate restructuring, right? So this is basically the kind of arrangement of the things we're gonna cover in the class. If you have any difficulty getting this textbook, just tell me. I'll try to see what I can do about it. And homeworks, right? So there will be 5 sets of individual homework questions during the semester. Basically, we will upload the homework questions, for example, after Wednesday's class usually, right? So it will be either on like Tuesday or like Wednesday morning. So basically, because I mean we have like Tuesday evening class, so it's either Tuesday evening or Wednesday morning the first thing. So that doesn't matter, right? So but the submission time is you need to submit it on or before the following Tuesday's classes. Right? Because we do online teaching, so you can email the scanned copy of the homework to me or TA. But preferably you should send the homework to TA, because TA is responsible for grading the homework. And that could be justified delays. For example, if you happen to be catching a very urgent deadline, that's just this justifiable delay. But justifiable delays should not be later than Thursday, right? And then during the semester, only 2 delays are allowed for students' homework questions. And the homework is preferred to be written in English. So this is the important thing. And that will be 20% that is taken away from the for the final individual report. So that's a basically mini project that each of you has to finish. And you don't need to worry about now, because I will announce the topics and the requirements on the last week of October. Right? And you will need to write a report for a topic in corporate finance. And meanwhile, you also need to present your report in 15 minutes, right? Because we cannot do, we are doing an online teaching, right? So each of you need to record a video and send it to me, right? So, I mean, just record a video where you're presenting a report and send it to me, or send it to our TA, right? And then the report is preferred to be written in English, okay, right? So this is basically the homework question and also final individual reports. And for the final exam, it's gonna be a 24-hour take-home exam, right? Again, it's gonna be later in the semester, but I'm just gonna tell you beforehand. It's gonna be a 24-hour take-home exam. So what I will do is I will send you a set of exam questions, which usually it's about 5 exam questions, and you can finish in 24 hours, right? Independently, of course, right? And then send the answers back to me through email, right? And then we will grade your answers onto the final exam questions. So this is how we're gonna do, right, for the final exam. So this is basically the requirements for this class. And if you have any other question, you can just ask me directly. Or if you have a question during this semester, just ask in the WeChat group or send me an email. Both methods are fine. Okay, now we're gonna talk about the first topic, which is present value and its applications. So this is the kind of basic first topic we're gonna touch on if we talk about corporate finance, right? Because a large chunk of corporate finance is dealing with valuation, right? I mean, and valuation to some extent it's very important, right? I mean, whether you are a financial manager or you're a financial analyst, right, who are writing an industry report, or you're working in an MA team in investment banking, and you're trying to working on the valuation of a target company, right? No matter what you do, you're gonna involve lots of tasks about valuation, right? For example, if you're a financial manager, you need to know how to value a project. If you're a financial analyst, you need to know how to value a company. If you are MA analyst, you also need to know how to value a target company that your client is thinking about acquiring. Right? So this is why valuation is very important. And knowing about present value or net present value is the fundamental kind of cornerstone of valuation, right? So that's why we need to talk about value. We need to talk about present value and its application as the very first topic in corporate finance. And we're gonna cover 4 topics. First one is the calculation of present value. Second, NPV as an investment criteria. Third one, alternative investment criteria. Right? So this is alternative criteria that do not use NPV. Finally, investment decisions using NPV. Right? So let's start from the very basic thing, right? Present value and future value. In other textbooks, we will call it like the time value of money. We need to recognize the time value of money when we do valuation, right? Because if you think about valuing a project, right, because you want to invest in it, or if you think about valuing a company because you want to buy it, it's gonna be a long-term project, right? It's gonna be a um, long-term period that you need to live up with your project, live up with the company that you buy, right? So it is important to recognize the present value of the cash flows of the projects that you're taking, right? Then does present value matter here, right? Because there is time value of money, right? Because over time, money is going to generate value, right? The reason is because if you invest your money in a particular project, you buy this company using your cash, right? You are basically committed to invest to kind of putting your money into this project, into this company, right? So therefore, you are giving up your opportunity to earn the alternative return on the money that you invested, right? Suppose the project does not have any risk, right? You are actually sacrificing the return that you can get from investing in a safe asset like treasury bills, right? This is kind of idea, right? So because you are sacrificing the alternative investment opportunity by investing in this particular project, therefore, we need to recognize this present value. So present value basically means the value today of a future cash flow, right? This is like how much is 1,000 tomato worth today, right? So why it's important? Because we all know that a very simple matter of fact is that if you deposit $1,000 today, you're gonna get more than $1,000 tomorrow, right? So therefore, the present value of $1,000 tomorrow is gonna be less than $1,000, right? As of today, right? Because you can accumulate interest by depositing into the bank, right? So this is kind of my idea. So on the other hand, future value is the amount to which an investment will grow after earning interest. All right. So for example, if you deposit $1,000 today, how much you will get after 5 years? This is kind of future value of $1,000. Right? And then the discount factor measures the present value of a dollar received in year T. Right? This is the discount factor. So this is the basic three concepts. And how do we calculate future and the present value, right? Again, I guess you guys were probably very familiar with these concepts, right? So future value is the initial investment times 1 plus R to the power of T, right? This is assuming the implicit assumption here, we are doing continuous compounding. Continuous compounding means that interest is compounded, right? For example, I deposit $1,000 today into the bank, right? And suppose the interest rate is like 10%. I'm basically gonna earn $100 after a year, right? And then at the end of the first year, what's going to be in I mean what's going to be the interest in the second year is gonna be $1,100, right? Then the interest rate is gonna be the interest rate is gonna be 10% again, right? So in that case, after 2 years, I'm going to earn 1,000 times 1 plus 10% to the power of 2, right? So that's why it's compounded interest, right? And because future value is initial investment times 1 plus R to the power of T, the present value can be calculated as this is the future value, right? Divided by the discount factor. So this is what we call the discount factor, right? So how much is $1 worth of today, right? So how much is $1 after T periods worth as of today, right? This is the discount factor. 1 divided by 1 plus R to the power of T, right? Now, for a simple example, right, suppose you have initial investment of $100 and the compound rate is 7%. Then this is the future value, right? Future value is 100 times 1.07 to the power of 2, right? Which is 114.49, right? And the discount factor here is 1 divided by 1.07 to the power of 2. And what you get is 0.8704, right? This is the discount factor. Right? Now, the other way, I mean, we can calculate the present value, right? The present value of this future value, C2, it's going to be discount factor times the future value equals this number times this number, right? Equals $100, right? So we're going back to the initial investment by using this present value calculation, this formula here. So then we're going to look at an example, right? So how do we value an investment opportunity, right? So basically, we use the above mentioned formula to do this calculation, right? So suppose you own a small company that is thinking about construction of a suburban office block. And the cost of buying the land and constructing the building is 700,000, right? And your company has cash in the bank to finance construction, right? And then your real estate advisor forecasts that there is a shortage of office space and predicts that you will be able to sell next year for $800,000, right? In that case, the rate of return is 14.3%, right? That is 800,000 minus 700,000 divided by 700,000, right? That is 14.3%, right? So this is rate of return, very simple calculation. So we haven't involved present value and future value calculation here yet, right? Now, so basically, if you're thinking about investment, you can invest in the project or paying out cash to shareholders. You don't have to invest, right? So we can assume that they can earn a 7% profit by investing for 1 year in safe assets, right? Like US Treasury debt security, right? Alternatively, they can invest in the stock market, which is risky but offers an average return of 12%. Right? So now you can see this is why here the return matter here. Right? The 7% is lower than 12%. Well, why? Because 7% is a return on a safe asset. It is a riskless payoff, right? The 12% is high because it is a risky investment. All right. Now, if your project that you think about investing, which is this project, right? Because here we say that a real estate advisor forecasts that the office space will be sold for 800,000 for sure, right? Therefore, it's a riskless investment. It does not have any risk in the project, right? So in that case, the opportunity cost of capital is going to be 7%. Right? Why? Because whenever we use the opportunity cost of capital, we should use the one that matches the risk of the project, right? Because this is the alternative return you can get by investing, right? By bearing the same level of risk. This is the very important. This is a very important thing. Yeah. We cannot use 12% because that's not a fair comparison because our project is a safe project without any risk, right? So that's why when we think about opportunity cost of capital, we should use the return that we can get by investing in a riskless project elsewhere in the stock market, for example, right? So if our project is as risky as investing in like Tesla stock, right? So in that case, the opportunity cost of capital of investing this particular project is the return from investing in Tesla's stock. Right? Now you can see what is opportunity cost capital, right? This is the minimum return or the expected return investors should be able to get by investing in other financial assets, right? Not this project, other financial assets that have the same level of risk, right? Elsewhere, right? In other words, this is the return that shareholders or investors give up, right? And give their money to the financial manager to invest, right? This is the kind of idea. So in our first example here, the shareholder will vote for the investment project, right? Because obviously the project offers a safe return of 14.3%, right? Right, but the opportunity cost of capital or the expected return from the shareholder, that it's only 7%. Right? So obviously this project is a winner, right? So shareholders should be happy about it. Right? So this is our first example. Now, the important concept that we need to kind of recognize when doing valuation is the net present value. Yeah, so present value is not enough because present value only tells you the present value of the cash flows that generated from the project, right? But any project involves the initial investment, right? So we need to recognize or incorporate the initial investment in our calculation of the net present value of the project. In other words, the net benefit of taking the project. Right? So if you have one period project, it's going to be C0 plus C1 divided by 1 plus R, right? And this is the present value, right? So if you have net present value that has multiple periods, then it's going to be this term minus C0, right? So this is the way to calculate. So in our first case, the present value, right? So you get 800,000 for sure, right? So an opportunity cost capital is 7%. Therefore, present value is this number, right? And then your initial investment is 700,000. Therefore, NPV is this number. All right, so very easy calculation. Now, we need to recognize risk when we calculate NPV, right? So, and the risk is reflected in the opportunity cost of capital or discount factor that we use, right? And the opportunity cost of capital is essentially the discount factor we use to discount future cash flows, right? And basically, the basic principle here is that a safe dollar is worth more than a risky dollar, right? Simply because uh, it's simply because you use a higher discount factor to discount a risky dollar, right? Because the opportunity cost of capital from a risky dollar is much higher than the opportunity cost of capital of a safe dollar, right? So like the previous example that I just talked about, right? If your project is as risky as a Tesla stock, right? Then the opportunity cost of capital or discount factor you need to use is the expected return from investing in a Tesla stock, right? That's kind of the idea. So suppose we stick with the first example, but now 12% is the opportunity cost of capital, right? So which means the project is no longer safe, right? So that means the 800,000 cash flow is not for sure, right? So in that case, we're gonna attach a higher discount factor to the cash flow. So in our case, it's gonna be 12%. So in that case, NPV here is gonna be this number, right? Now, if you compare this NPV with the previous NPV, or with the previous PB, right? So for example, this number here, it's gonna be lower, right? Right, so because why? Because it's a risky dollar, right? You use a higher discount factor, higher opportunity cost of capital to discount your future cash flows. So basically, the rate of return here is simply the profit as a proportion of the initial outlay, right? So this has nothing to do with NPV. And the cost of capital here is the return forgone or the return given up by not investing in financial markets, right? So here, uh, if we invest, we can get 14.3% return, right? So this is like the internal rate of return. So I mean, this concept we're going to talk about later, but this is like return, right? And then this return is much higher than the 12% opportunity cost of capital. Yeah, so still this is higher than 12%, right? So previously we compare 14.3% to 7%, right? So this is when the project is safe, right? No, suppose the project is risky, but it is not that risky, right? So the opportunity cost capital, it is still like 12%, lower than the return we earn, right? In that case, you should still go ahead with the project, right? Now, the net present value rule says that we should always accept investment, right, that have positive NPV values. And the rate of return rule says that you should always accept investments that offer rates of return in excess of the opportunity cost of capital. This is kind of idea. So what's the intuition here? The intuition again is that what is the opportunity cost of capital, right? This is the minimum return or the expected return shareholders they want if they don't give you money to invest, right? If they invest the money elsewhere on their own, right? The alternative return they can get, right? So in order to kind of make shareholder happy about giving you their money for you to invest, you need to make sure that the return you can deliver must be the expected return they want to have, right? Otherwise, they can take the money away and then invest elsewhere, right? In the financial market, for example. So this is kind of idea. Now, if we have multiple cash flows, then NPV is going to be this way, right? So C0 plus, this is the sum of the future cash flows, right? So here, this should be a small t, right? So there's a typo here, it should be smaller t. So for example, suppose your advisor suggests that you will rent out the building for 2 years at 30,000 a year, and predicts that at the end of the time, you will be able to sell the building for, let's say, 840,000, right? So in that case, there'll be 2 future cash flows, right, rather than 1 future cash flow. So in that case, we can calculate the present value, all right? So this is the initial investment. This is the present value of the two cash flows, right? Then we can get this number, right? So this is if we use NPV, right? So this is how we calculate. Now, again, to kind of review the concepts of opportunity cost of capital, right? So opportunity cost of capital is how much investors in the financial markets, they pay for security that produces a similar stream of future cash flows, right? And typically that's not a bank loan rate, right? So why this is not a bank loan rate, right? So think about what is the bank loan rate, right? So if you borrow from the bank, right, the bank typically does not really care what kind of project risk you are taking, right? They only care about whether you can pay back the loan, right? So, and think about when will a company not be able to pay back the loan, right? Only when a company goes bankrupt, right? This is the time when the company cannot pay back the loan, right? So if a company is taking a very risky project, or if a company is taking a less risky project, as long as the company is still able to repay the debt, the bank really doesn't care, right? Because I mean they know that they're gonna be repaid, right? So why do they care? What kind of risk the company is taking, right? Of course, I'm not saying they don't care about the risk in any case, right? But in general, they are not that sensitive to the project risk the company is taking, right? So that's why the bank loan rate is usually pretty low, right? So because that's the return that the banks expects the company is gonna deliver, right? So and it's not very high, right? Because it doesn't have to be really high, right? So therefore, the opportunity cost of capital is not a bank loan rate because opportunity cost of capital reflects the kind of reflects the risk of the project essentially, right? If the project is more risky, the opportunity cost of capital is higher. If the project less risky, opportunity cost of capital is lower, right? So this is kind of idea. But bank loan rate, it's about the overall default risk of the company, right? As long as the company's default risk is really low, then bank loan rate is going to be low, right? This is kind of the idea. Now we have talked about the basic ways to value a company, value cash flows, right? So we can also apply the formula elsewhere, right? So when we try to value different cash flow, different patterns of cash flow, right? So we can use the NPV formula to value perpetuity, right? Perpetuity is essentially you have a type of claim, and this claim delivers fixed cash flow each year to forever, right? There's no end to this claim, right? So that's why it's called perpetuity, right? So because the cash flow is going to be perpetual, right? So and it will be like bonds that the government is under no obligation to repay, but they offer a fixed income for each year to perpetuity, right? Even if in reality that kind of bond doesn't really exist, right? But in many cases, there will be bonds that are similar to this kind of perpetuity, right? For example, like 30-year, 50-year, 100-year bonds, right? Then in that case, the present value of this kind of bond is could be simplified as the cash flow each period divided by the the interest rate or the discount factor, right? So this is kind of idea or the return, right? So and we can also use the NPV formula to value annuity, right? So annuity is an asset that pays a fixed sum each year for a specified number of years, right? So for example, the equal payment house mortgage, this will be like an annuity, right? And insurance to some extent is also like an annuity, right? So this is kind of idea. So then we can further simplify the formula of NPV, right? So the present value is going to be C is the cash flow each period times 1 divided by R minus 1 divided by R times 1 plus R to the power of T, right? And then we call this one here as the annuity factor, right? This is the annuity factor. And then, for example, the present value of a 3-year annuity of $1 a year is going to be this one, right? So as the T here is the horizon of this annuity. Right? Now let's look at one numerical example, right? You can use the NPV formula to calculate on your own, right? A price of this 590.5 million is to be paid in 30 equal annual installments, right? As these payments, they constitute a 30-year annuity, all right? And then how do we value this annuity, right? Basically, this is the annual payments we need to take into account, right? Annual payment times the annuity factor, right? Times annuity factor. This is the present value you're gonna get. And suppose we have an equal payment bank loan, right? Suppose you have take out a 4-year loan of $1,000, and then the bank requires you to pay the loan evenly over the 4 years. That means that there's equal payment over these 4 years, right? And then I must therefore set the 4 annual payments so that they have a present value of 1,000, right? So basically, the present value is going to be the annual loan payment times the 4-year annuity factor, right? Then we know that you take out the 4-year loan of $1,000 today, right? So therefore, 1,000 is the present value, right? So then annual loan payment is going to be the present value of the annuity, which is $1,000, which is the present value of this loan, divided by this annuity factor, 4-year annuity factor. And suppose the interest rate is 10% a year, you can calculate the annual loan payment by using the formula. Right? This is the formula for annuity factor. Right? And another example here, I suppose you take out of 250,000 house mortgage, right? Again, this is an equal payment mortgage. Interest rate is 12%. The horizon of the mortgage is 30 years, right? So which is a common horizon for mortgage, right? Then annual mortgage payment was going to be, this is the present value of the mortgage, 250,000 divided by the annuity factor, right? Then the annual mortgage payment is going to be 31,036, right? So this is kind of idea. And another way to use NPV to calculate some kind of special version of the claim is the growing perpetuity. We use that to calculate growing perpetuity, right? So the difference between growing perpetuity and perpetuity is that the cash flow in a growing perpetuity actually has a growth rate. Right? For example, the growth rate is 10%, 5% a year. Right? In our case, the present value of growing perpetuity is going to be C1 divided by R minus G. Right? So G is the growth rate of the cash flow. And this formula is actually quite commonly or widely used when we calculate a dividend growth model. All right, because in that situation, we assume that dividends grow at a fixed rate, right? Like 5%, 10% a year. So in that case, and then we think that the value of a stock actually comes from dividend payments in the future, right? So therefore, the left-hand side is going to be the value of the stock, right? Will be equal to the present value of this growing perpetuity, right? Or a stock that pays dividends and the dividend grows over time. Right? So this is the kind of idea. Now we're gonna revisit the dividend discount model later in the class. And of course, you can have a growing annuity, right? In which case, the cash flows in the future grow at a constant rate, right? So in that case, G is the growth rate of the cash flows. C is the initial cash flow. Right? So to recap, so how do we calculate NPV, right? So we first forecast the cash flows generated by the project over the economic life, right? And then second, we determine the appropriate opportunity cost of capital, right? And then this should reflect both the time value of the money and the risk involved in project. So again, higher the risk, the higher the opportunity cost of capital, right? And we can use the opportunity cost of capital to discount the project's future cash flows, right? And then what we get is the present value, right? And finally, we can calculate the net present value by subtracting the initial investment. So our decision rule here is therefore whether NPV is greater than 0 or not, right? If the NPV is greater than 0, then we pick the project. If NPV is less than 0, we don't take the project. All right? This is the kind of idea. I mean, it's quite intuitive, right? So if the present value of the cash flows do not exceed the initial investment, that means the project is going to be a failure. It's going to be a loss, right? So there's no point in taking the project. So basically, if we use NPV as the investment criteria, the way that it works is the financial manager, they get cash, right? So they get cash, for example, from company's earnings, right? From company's operation. So they can use the cash to invest in a particular project, right? Of course, conditional if the project's NPV is greater than 0, right? So this is the pre-assumption. The other way financial manager can play around with the money is that they can pay out the cash to shareholders as a dividend, right? So we can talk about dividend policy later in the class, but I mean, as a common sense, we all know that firms can pay out cash to a dividend, right? So, and if so, in our case, they don't use the cash to invest, right? So therefore, this is the alternative way to kind of pay out the cash, right? Shareholders, they get a cash and then shareholders invest for themselves elsewhere in financial assets, right? So therefore, the opportunity cost of capital is the alternative return shareholders get by investing in the financial assets, right? Conditional, they don't allow the money for the financial manager to invest in this project. So therefore, to make shareholders satisfactory, to make shareholders happy by agreeing to sacrificing the dividend and allowing financial manager to invest, the projects must deliver the return that is higher than the return shareholders they can get from investing financial assets, right? This is kind of idea. And there's 3 rules about NPV, right? So again, $1 today is worth more than $1 tomorrow. Net present value depends only on the forecasted cash flow from the project and also the opportunity cost of capital. And then NPV can be added up, right? So this is also important. If you take, sometimes you want to take into account 2 projects together, right? So in that case, you need to add up the NPV of these 2 projects together and then make a decision. Right? Of course, there are not just one way to decide whether to take the project, right? NPV is the kind of standard way, but there are also other ways to think about whether to take the project or not. One decision rule there is called internal rate of return, right? This is very similar to like the rate of return that we talk about in the beginning, right? So the rate of return of the project basically. And the kind of more detailed name for it is called internal rate of return, right? And the other the other kind of decision criteria is called profitability index, right? So we're gonna look at several alternatives to NPV decision criteria, and we're gonna evaluate their weakness, right, and their advantages, right? But the overall conclusion is that we should always stick to NPV whenever NPV is easier to calculate, right? Because for each alternative method, there's always a limitation that will create troubles when we use that kind of decision criteria. The first one we're going to look at is the payback period, right? So payback period is essentially counting the number of years the project takes before the cumulative cash flow equals the initial investment, right? For example, if we invest $10,000, right, we are interested in how many years we are able to get this $1,000 back, right? This is the kind of idea. The payback rule essentially says that the project should be accepted if the payback period is less than some specified cutoff period, right? I mean, in other words, that's the number of break-even years, right? You invest $1,000. You ask yourself, how many years does it take to break even, right? And the payback period rule can sometimes give misleading answers, right? So therefore, it can only be used as like a supplementary criteria, right? So for example, if two projects they both generate higher NPV, right? Then in that case, you might think about which one gives you which one gives you a shorter payback period, right? So they cannot use as a main criteria for judging whether to take the project or not, right? So because obviously the payback rule has this weakness, right? So it ignores all cash flows after the cutoff date, right? Because you can have two projects, right? One project will give you large cash flows, high cash flow in the beginning. Another project gives you high cash flows in later in the project life. Initially, it has very low cash flow, right? So in that case, you might conclude that the payback period for the first project is really short. The payback period for the second project is really long. So therefore, you take the first project, right? But the conclusion is usually wrong, right? Because in many cases, the second project that has small cash flows in the beginning, large cash flows later in the future, will have a high NPV. Right? So that means from an NPV perspective, you might be better off just taking the second project, right? But from the payback rule, you might want to take the first project, which is suboptimal, right? This is the first weakness. The second weakness is that the payback rule actually gives equal weight to all cash flows before the cutoff date, right? They don't apply a discount factor, right? They don't recognize the time value of money. That's why it can be misleading. So for example, if we have three projects, right? So you can see what's the pattern of cash flow here. The cash flows of A is that they have small cash flows in the beginning, they have large cash flows in the third period, right? So therefore NPV is 2000-ish, right? For project B and C, the initial investment are the same as in A, right? But they have relatively higher cash flows in the first two periods, but zero payoff in the second period, right? So for NPV, you can see there's no question that you should take project A, right? Because the NPV is very, very high, right? But if you have a cutoff period at 2 years, right, you might actually wrongly conclude that you should accept projects B and C, right? Because they have a quicker payback period, right? Which is obviously wrong if you think about the value, right? So if you set cutoff period of 3 or more years, then you might conclude that you should accept all 3 years, right? So in that case, again, you need to use the NPV to help you make the decision. Now, the improvement upon the payback period is that you can use the discounted payback period, which essentially discount the cash flows and calculate the payback period, right? So again, the weakness is that it still doesn't take into account the cash flows after the cutoff date, right? So that's why it's a bit arbitrary, right? So therefore, it can never be used as a main decision criteria, right? It's usually used as a warning signal, right? For example, you have this positive NPV project, but it turns out to be that this project has a very long payback period, right? Maybe your shareholders are very myopic, your shareholders are very impatient, right? So this could be a warning signal because these shareholders could object to this project, right? So this is one example that uses the discounted payback method, right? So you can see if you set a cutoff period as 2 years, right, you should take project C. If you set payback period as 3 years, you should take project A and C. Right? Still, there's no clear answer to this question if you use payback methods, right? So the next decision criteria is internal rate of return, right? So how do we determine internal rate of return? It's essentially the rate of return that gives you the zero NPV, right? And what's the difference between internal rate of return and opportunity cost of capital? It's simple, right? Because internal rate of return is a profitability measure, right? It's the discount factor, it's the return that sends you the zero NPV, right? Sends you the break-even point, right? For opportunity cost capital, it's the standard of profitability, right? It's the minimum return that the shareholders they expect to receive, right? If they if they don't invest in your project and invest elsewhere, right? So it's a minimum criteria. That's why it's a standard of probability, right? But if you, but the internal rate of return, it could be anything, right? So as long as the NPV equal to 0, you can calculate the internal rate of return, right? This is kind of idea. So this is the way to calculate internal rate of return, right? Stand NPV equal to 0, right? So this is the one period example. If you have multiple periods, you set up multiple equations here, then you solve it, right? Usually we use Excel and or computer to solve this kind of equation, right? And the rate of return rule here, IRR rule here, is that we should always accept an investment project if the opportunity cost of capital is less than the internal rate of return. So in other words, we should make sure that the internal rate of return is higher than the opportunity cost capital, right, to take the project. This is kind of idea. One example here is that you have a project like that delivers cash flow pattern like this, right? Initial investment 4,000. This is the future cash flows in a few years, right? And then to make this NPV equal to 0, right? We can get the IRR should be between 0 and 50%, right? And the internal rate of return here should be 28%, right? So sorry, there's a typo here. Should be internal rate of return equaling 28%, right? So this is kind of idea. Okay, so now let's take a break, and then we'll take a break and we're gonna continue. Okay, so next we're gonna talk about different kinds of pitfalls of using internal rate of return rule. The first kind of weakness is that when we use IRR, there will be problem when it comes to lending or borrowing. Right, so the rule is gonna be flipped if we think about cash flow patterns when it comes to lending, and cash flow patterns when it comes to borrowing. So in this example, like if you look at project A, this is a typical case of lending, right? Because you lend out $1,000 in the first period, and then you get what you lend in the second period, right? You get 1,500, right? Then even if the IRR here is 50%, right? So this is the same as in scenario B, right? Scenario B, this is a borrowing situation, right? In the first period, you get $1,000, but in the second period, you pay out 1,500, right? This is a borrowing situation because in the second period, you have to pay back, right? So you can see in those two projects, if you use the IRR rule, they both deliver 50% return, right? But NPV is exactly opposite, right? Because for project A, the NPV is positive, right? You lend less, you lend out 1,000, you actually get paid back 500, right? This is a good bargain, right? But for project B, you actually borrow less, but you actually pay back more, right? So that's why NPV is obviously negative, right? In that case, from NPV rule, you should take project A, right? But IRR rule can actually differentiate between these two cases, right? The reason is that for lending situation, for case A, we want a higher return, right? Because if you lend out money, you always hope to get more, right? But in case B, right, if you borrow money, right, you always want a lower rate of return, right? Because in this case, you don't want to pay back a lot, right? You only expect the kind of borrowing rates it's going to be as low as possible, right? So in that case, for case B, we always want a lower return, right? So in that case, the IRR rule does not apply here, right? So in that case, for case A, this is consistent with the original IRR rule, right? So we always want a higher return. But for case B, we need to look for IRR that is less than the opportunity cost of capital, right? Because we want to find a lower borrowing rate. This is kind of the idea. The second weakness of IRR is that they may sometimes involve multiple solutions, right? Because we are solving this solving this higher polynomial equation, right? So there will be many cases where there will be multiple solutions, right? And typically, whenever the cash flow stream is expected to change sign more than once, right, like 500 minus 500, 500 minus 500, then in that case, there will be multiple solutions guaranteed, right? So in that case, we cannot use IRR anymore, right? So we have to calculate NPV separately to tell us which one to take, right? Now, so one example here is the 1,000 minus 3,000, 2,500. Right? This is a case where there will be two IRRs, right? So we cannot use IRR rule anymore to judge in these cases. A third weakness of IRR rule is that when it comes to mutually exclusive projects, there will be problems, right? In other words, the IRR decision rule will be unreliable when we use it to rank the projects of different scale and the projects of different patterns of cash flow, right? And the way to salvage IRR rule, or to kind of reuse the salvage rule, is we can look at the internal rate of return on the incremental cash flows, right? So not just look at the IRR of the separate cash flow, we look at the IRR of the incremental cash flows of one project relative to the other. So this is the example where you have mutually exclusive projects, right? In this case, we can think about the following situation, right? For example, project D is a manually controlled machine tool, and project E is the same tool with the additional computer control, right? So in that case, you cannot have both, right? Either you have the manually controlled machine tool, or you have you can have a tool where you add a computer control, right? That's why they're mutually exclusive. And both are very good investment, right? Because both projects deliver positive NPV, right? So if you look at NPV, maybe you should take project E, right? Because project E gives you a higher NPV, right? But if you follow IRR rule, that might suggest that project D is better, right? Because the project D gives you a higher IRR, which is 100%. Project E only has 75%, right? Now we have contradictory prescriptions from IRR decision rule and NPV decision rule, right? So in that case, we can look at the IRR of the incremental cash flows of project E relative to project D, right? So in that case, you can see initial investment minus 10,000. In the first period, cash flow, incremental cash flow is 15,000, right? So in that case, is 50%, right? So in that case, you can see we should take project E, right? This is the way to think about this. And another example here is when we try to compare these two projects, right? Project F and the project G. Now you can see the cash flow patterns of project F and the project G is also very distinct, right? Project F is a project that gives you very high cash flows in very short periods, right? But project G is a cash flow that gives you cash flow in a very smooth pattern, right? Every period the cash flow is the same as like 1800, but it gives you the same amount of cash flows forever. It's like a perpetuity, right? But for project F, this is not like that, right? It gives you high cash flows in the first 3 years, then it's down. Right? If you calculate NPV, you can see project G has a high NPV, right? We should take project G. But if you calculate the IRR, you can see that the decision rule of IRR tells you that you should take project F, right? Because project F, the IRR is 33%, right? Project G has a 20% internal rate of return. Right? Now again, we have contradictory prescriptions for IRR rule and NPV rule, right? Now if we plot the discount rate and the NPV of these two projects, you can see a clear pattern here, right? That is, if the IRR or the project or the discount rate is higher than 15.6%. In other words, if the discount rate is high, project F has a high NPV, right? If the discount rate is low, project G gives you a high NPV. All right, so this is the pattern, right? So you can see the total cash inflows of project G is larger, but tends to occur later. This is the pattern, right? This is the pattern we just talked about, right? And then the discount rate also has this pattern, right? That is when the discount rate is low, right? Especially lower than 15.6%, project G is better, right? This is kind of idea. So now if the opportunity cost of capital is 10%, this where it falls into the region where the discount rate is low, right? In that case, we should take project G, right? Because project G gives you the high NPV in that case, right? This is how we decide. This example actually has very practical implication, right? Because if we ask like financial managers in practice, which one will they kind of take? Most of the people will choose project F, right? Because in the future there might be capital constraints, right? So in real life situation, it's not very common that the company is always financially flexible, always, right? So that there's risk of facing financial constraints in the future, right? So therefore, people like project F, right? Because project F delivers to quick and high return, quick and high cash flows, right? In the near term. Whereas project G, it has a very smooth but very low cash flows in the beginning. So for example, if there's a financial crisis 4 years later, then project G is pretty much finished, right? So that in that case, you might want to take project F, right? Because it gives you quick and high cash flows immediately, right? And here the reason our rule fails is exactly because of this constraint, right? It is because the problem now, it's not just finding the project that gives you the highest return, right? It's to find the package of investment projects that satisfy both conditions. That is, we need to find a project that can satisfy the capital constraint, right? For example, it can satisfy the capital constraint in the near-term future. And then it can also delivers the largest NPV, right? So the kind of purpose, the objective function here is like double or do, right? So therefore, that we cannot no longer use internal rate of return to kind of make a decision. And that's why we need to find this way out, which is we can look at the incremental cash flows of project F from project G, right, to find out the best project. And then the conclusion we get from looking at the incremental cash flows, it is still that we should take project G. Right? So this is the kind of idea. Now, if we extend this kind of idea further, right? Suppose we suppose our resources are limited, right? And in that case, we need to choose capital project. Right? So this is similar to this example here, but it has implicitly or explicitly taking into account this capital requirement, capital constraint into account, right? So we have 3 projects, A, B, C, right? So project B and C, they have very low initial investment, and of course their cash flows are also lower in the next 2 years, right? Project A involves very high initial investment. Of course, their future cash flows are also on average high, right? So from the NPV method, it seems to indicate that firms should take project A, right? Because project A delivers the higher NPV than project B and C, right? Now suppose we have this constraint, which is the firm is limited to spending 10 million and the opportunity cost of capital is 10%, right? In that case, we can introduce the other kind of criteria to make a decision, which is the probability index, right? When the funds are limited, we need to pick the projects that gives you the highest NPV per dollar of initial investment or per dollar of initial outlay, right? So in that case, probability, we can calculate the probability index as NPV divided by initial investment, right? So which is, for project A is 21 divided by 10, is 2.1. For project B is 16 divided by 2, right? So in that case, it's 2.8, right? For project C is 12 divided by 5, right? Which is 2.4, right? So in that case, you can see project B has the highest probability index and the C is the next, right? So in that case, if we consider probability index, it seems that we should accept B and C, right? Because it satisfies the capital constraints, right? Which is 10 million, right? And if we take project B and C, because NPV can be added together, right? If we take these two projects all together, we have NPV of 28, right? Which is higher than the 21 if we take project A alone, right? We should accept these two projects, right? Right, and you remember that this kind of suggestion is both recommended by using the probability index and following the simple NPV rule, right? Because the simple NPV rule tells us that if we can take B and C together, right, this generates a high NPV than taking project A alone, right? Now, we can see if we stick with probability index, that can also have some problem, right? So this example shows that suppose we have multiple resource constraints, right? Then probability index can fail, right? So multiple resource constraints means that we face capital constraints in multiple periods, right? So suppose that a firm can raise only 10 million for investment each of the years 0 and 1, right? Now, notice that we have capital constraint in both year 0 and 1, right? So in that case, we have two options, right? Which is to accept B and C, right? And or accept A and D, right? So A needs spending 10, D needs spending 40, right? In the second period, C needs spending in the first period of 10, right? So you can see accepting B and C and accepting A and D, these are two options that satisfy the capital constraints, right? Now, A and D, they have lower probability index than B and C, right? But they have a higher total net present value, right? And you can see there seems to be a contradiction between probability index and net present value, right? If we follow net present value, that seems we should pick A and D, but if we follow probability index, that seems we should take B and C, right? So you can see obviously we should take project A and project A and D, right? Because that gives you a higher NPV, right? Because NPV can be added, right? So the reason is that the ranking method, it could be inadequate whenever there's any other constraint on the choice of projects, right? So to summarize, we should follow these 4 rules when we make investment decision, right? So first of all, only cash flow is irrelevant, right? Second, we should always estimate cash flows on an incremental basis, right? Because that can guarantee the consistency between our rule and other NPV rules, right? Also, we should be consistent with treatment of inflation, right? And then we should separate investment and financing decision, right? Lending or borrowing should be separate, right? So for the first requirement, right? Only cash flow is irrelevant, right? This is where capital expenses make a difference, right? So when we calculate NPV, we should always state capital expenditure when they occur, right? And it could be problematic if we recognize capital expenses as depreciation, right? Because I mean, the reason why this is important is that when we do valuation projects, we usually are given financial statements, right? And then who make these financial statements? These are the accountants who make financial statements, right? The accountants, so from the financial statement to cash flow, we need to do some calculation, right? Because when accountants make these financial statements, they think it from the perspective of accountants, right? From accounting, not just from a cash flow perspective. right? So that's why to go from accounting income to cash flow, we need to add back depreciation, right? Because depreciation is not a direct cash outflow. So therefore, we need to adjust accounting income to get cash flow. In that case, we also need to subtract capital expenditure, right? This is really a cash outflow, right? Suppose you buy a machine. Now, suppose you buy a car, right? So these are all capital expenditure. And the other thing we need to take into account is the working capital. Right? When we calculate cash flow or net cash flow, we should always take into account working capital. Right? So when accountants measure income, they always try to show profit as it is earned, right? Rather than when the company and the customer get around to pay the bills, right? So therefore, we need to adjust those accounting income to get our cash flows, right? So let's look at one example here. Suppose there's one investment proposal that costs you $2,000, and then this investment proposal is expected to provide a cash flow of 1,500 in the first year and 500 in the second year, right? And suppose the capital expenditure, that is the 2,000, is depreciated over the 2 years, right? Then if you calculate accounting income, you need to recognize depreciation, all right? So in the first year, depreciation is 1,000. In the second year, depreciation is also 1,000, right? So in that case, the accounting income in the first period is 500, right? Because it's 2,000 minus 1,000. In the second year, it's minus 500 in the second year, right? So that is 1,500 minus 1,000, right? So in that case, OCC equals 10%, then we can get NPV as positive, right? Now, you can see obviously this is wrong, right? Because the NPV of this project under OCC equals 10% is definitely negative, right? So that means from the cash flow, from NPV perspective, you should always reject this project, right? But if you take into accounting income, that could be misleading, right? Because depreciation is not a cash outflow. Capital expenditure, it is indeed a expenditure, right? Because if you think about NPV using accounting income, right? Capital expenditure in accounting income, they are not actual expenses. They are not cash outflow. They regarded as investments, right? But depreciation in accounting, they are regarded as cash outflow, right? So therefore, you can have this misleading answer here. So now let's look at another example here, right? So suppose you have this project, right? So in the first period, the cost of producing goods is $60, right? And the firm produces goods in the first period and receive customer bills or receive the customer payments, or they sell the product to customer. Customer pay the bill in the third period, and then they receive 100, right? So in that case, if you are accountants, right, you'll try to adjust for period 2 cash flow, right? So the basic idea is that in the period 2 cash flow, it's going to be the revenue minus cost of goods sold, right? Because the cost of goods sold is 60, right? The revenue here is 100, right? Because the idea is that the $60 cash outlay in the first period, it will be treated as the investment in inventory. So in that case, in the first period, investment in inventory increased by $60. Right? And then in period 2, the accountant shows a $60 reduction in the inventory, right? And then the second period, the sale is made, the sales transaction is made, right? The accountant will record accounts receivable of $100, right? And then later, when the customer paid the bills in period 3, accounts receivable will go down by 100, right? So you can see this is the accounting way of treating those cash flows, right? Treating those cash flows, right? So for accounting income, in the first period, it is 0, right? Because in the first period, the inventory goes up by $6, right? In the second period, the sales are being made, right? So revenue increased by 100, inventory goes down by 60, right? So that means the accounting income is 40, right? And in the third period, the accounts receivable go down by 100, right? So that means the accounting income is 0, right? Now, what we see usually is the financial statements, right? So therefore, we need to adjust the accounting income to get a cash flow. Again, we always give you the assumption about the cash flow, but in actually real life, you're almost always just giving financial statements, right? Which are made by accountants, right? So therefore, in many cases, we need to adjust accounting statements to get cash flow, right? But this is one way to do it, right? So in the first period, accounting income minus investment in inventory and minus the investment in the receivable, we're gonna get cash paid out is minus 60, right? And then in the second period, we need to use accounting income to minus the investment in inventory, which is 60. And then we should also subtract the investment in receivable, right? Which is 100, right? Which is 0, right? Then in the third period, we need to do this calculation again. In the third period, investment inventory is 0, right? Because products are sold already. But in the third period, so the investment in receivable goes down by 100, right? So in that case, that should be positive 100, right? So in that case, the cash flow is negative 60 in the first period and 100 in the third period, right? So in that case, we can adjust our working capital to get a cash flow, right? So basically, net working capital is the way we adjust capital, right? So it's the difference between a company's short-term assets and liability, right? Here, the accounts receivable and inventory of raw materials and finished goods, they are the principal short-term assets, right? Of course, accounts payable, they are the short-term liabilities, right? And also, of course, taxation there. So each period's change in working capital should be recognized in your cash flow forecast. Right? So this is the way to get cash flows. Later, we will see one example, right? And the second rule here is that we need to estimate cash flows on an incremental basis, right? We should always remember to include taxes, and we should all include all incidental effects, right? For example, the new products will benefit existing businesses, right? So the loss in the existing businesses should also be taken into account, right? And we should always forecast sales today and recognize after sales cash flows to come later, right? And then we should always include opportunity cost, right? If you own, suppose you are self-employed, right? So you actually run a cafe by using your own houses, right? So in that case, there will be opportunity cost of using your houses, right? Because if you don't run the cafe in your house, then you can rent out your house. You can earn a rental income, right? So this is the opportunity cost. And we should always forget sunk cost, right? Sunk cost means the cost before you make a decision, right? And also we should be aware of allocated overhead costs, right? For example, you are taking a project, right? But there are many projects that happen at the same time, right? And then you both consume, let's say, office supplies. You both consume electricity, right? So then the overall electricity bill will be allocated across all different projects. So therefore, that should also be recognized, right? This is called the overhead cost. And also we need to remember the salvage value. So what is salvage value? Salvage value is you buy a machine initially, right? After 20 or 30 years, the machine becomes, let's say, worthless, right? You wanna liquidate it, right? This is the remaining value of this machine on the market, what we call a salvage value, right? And rule 3, we need to treat inflation consistently, right? So if the discount rate is nominal return, right, we should use the nominal cash flow. If the discount factor is real interest rate, we should use the real cash flow, right? Finally, we should separate investment and financing decision, right? So we should not subtract the debt proceeds from the required investment, right? These are different, right? Because debt is about financing, right? Investment is about investment, right? And we should also not recognize the interest payments on the debt as cash outflow, right? Because we should only evaluate the cash flows generated from the project. Now let's look at this example here. This example, you can see this is the IMC's fertilizer project, and it's on the textbook, right? So initial investment is 10, right? 10,000, just abbreviation, 10,000. The salvage value is 1.949, right? Salvage value here. And then we can calculate the annual depreciation as initial investment minus salvage value divided by 6, right? Because that's 6 years, right? This is annual depreciation. And how do we calculate net cash flow? This table already shows you how to do it, right? It's the cash flow from capital investment disposal plus cash flow from changes in the working capital plus operating cash flow, right? So this is the way to calculate net cash flow. And the row 2 is the change in the working capital, right? And operating cash flow, how do you calculate it? This is given in line 3, right? It is revenue minus cash expenses minus taxes, right? So this is one example of calculating operating cash flows, right? So now we can calculate NPV, right? Because NPV is just the initial investment plus the discounted present value of the net cash flows, right? And the opportunity cost of capital is 20%. Yeah? So this is the net present value. Very easy calculation. Yeah? Now let's look at the investment in working capital. So the working capital summarizes the net investment in the short-term assets associated with the firm business of the project. Right? If we look at the working capital in year 2, right, it's going to be line 4, right? It's working capital is, so it's on the book, there's another table that shows the level of the working capital, right? It's going to be 1,289, right? And suppose this number we can get from inventory plus accounts receivable minus accounts payable, right? Suppose there's no tax, right? So then the additional investment in the working capital, which is 1,972, is going to be increased in the inventory plus increase in accounts receivable minus accounts payable, right? So now you can see why working capital increases, right? It could be accounts receivable increases. It can also be inventory increases, and also be accounts payable decreases, right? And it could be one of the 3 factors or 3 factors both are acting together, right? So one example of accounts receivable increase is that, for example, the sales recorded on the income statement overstate the actual cash receipts, right? And the customer, they are slow to pay, right? So therefore, accounts receivable should increase, right? And also inventory can also increase, right? For example, it can take several months for the processed guano to age properly. So guano is kind of the products we're talking about here. An offsetting effect can also occur when the payments for the materials are delayed, right? In that case, accounts payable should also change, right? So this is the several reasons why working capital increases, right? And this is the detailed cash flow forecast in year 3, right? That incorporates the working capital composition, right? And additional investment in working capital. So the final note on depreciation is that if we think about depreciation, right? Depreciation has this advantage is that it provides annual tax shield equal to the product of depreciation and marginal tax rate. And how do we calculate this tax shield? It's depreciation times tax rate, right? And accelerated depreciation actually allows companies to get tax shields sooner, right? So There are mainly two ways of depreciation, right? Straight line depreciation means that each year there's an equal amount of depreciation. Accelerated depreciation means that there is greater depreciation in the initial periods and the slower depreciation later. So this is accelerated depreciation. So finally, we talk about how do we use the NPV rule to choose among projects, right? And mainly there are 4 problems inherent in this decision. The first problem is called the investment timing problem. The second problem is the choice between long and short-lived equipment. The third problem is called the replacement problem, right? The final problem is called the cost of excessive capacity. Basically, these are the 4 problems we need to kind of recognize. So let's first look at investment timing problem. Right? So investment timing problem essentially means that qualitative NP projects, they might be better taken in the future. Right? And then in that case, we can calculate the net present value of investment if taken at date t. Right? This is the net future value at date t divided by the discount factor. Right? So the idea is like investment in a timber, right? Suppose you own a large tract of inaccessible timber, right? And to harvest the timber, you need to invest a substantial amount in access roads and other facilities, right? And then the longer you wait, the higher the investment that you need, right? Of course, on the other hand, if you wait longer, the lumber prices are also gonna be higher, right? So in that case, you're gonna get more revenue. And at the same time, the trees will keep growing, right? Of course, they will grow at a decreasing rate, right? So that's why there is investment timing problem there. So let's look at this example, right? So obviously, you can see the longer you defer cutting the timber, like 1, 2, 3, 4, 5 years, the more money you get, right? So the higher the net future value, right? And I suppose the discount rate is 10%, we can calculate the net present value if harvesting year 1, right? So that is net present value times the discount factor, right? Right? And then we can then calculate the NPV for all other harvested dates, right? And we're determining the optimal year to harvest, right? So how do we determine the optimal harvest year? It's going to be the year where the present value of the net future value is going to be highest, right? This is the optimal year. It turned out to be the year 4, right? The second problem is how to choose between long and short-lived equipment, right? So suppose the firm is forced to choose between 2 machines, A and B, right? Machine A costs 15,000. Machine B costs 10,000. But the difference is that machine A will last 3 years, right? And it costs 5,000 per year to run, right? And then machine B costs only 10,000, but it will last only 2 years, right? And then it also has a higher maintenance cost, right? It costs 6,000 per year to run. Now you can see if we calculate the present value of B, it's going to be lower, but annual cost is not, right? You can see annual cost of B is higher than A, but the net present value, no, sorry, the present value of cost of running B is lower. Right? Now we can calculate the concept of the equivalent annual cost, right? To calculate which one costs lower to kind of run, right? So the equivalent annual cost we can be calculated as the 3-year annuity with the same PV as A's lifetime cost, right? This is the way to find an equivalent annual cost, right? So the present value of the annuity, this is the present value of operating operating machine A, right? That's 28.37, right? So this is just calculate the present value, right? And then this present value will be equal to annuity payment, right? This is the equivalent annual cost times the 3-year annuity factor, right? And then this annuity payment, which is the equivalent annual cost, is going to be 10.61, right? And in that case, machine B gives you a higher equivalent annual cost, which is 11.45. Right? In that case, we should conclude that machine A is less costly to run. Right? This is the kind of conclusion we can get. And then we can take into account the inflation and technology change, right? Because the cost of buying and operating a machine will likely rise with inflation, right? We can calculate equivalent annual cash flows in real terms, right? So suppose new machines cost 20% less each year in real terms to buy and operate, right? So in that case, we can assume that the real level rent declined by 20% a year, right? Then we can calculate the equivalent annual cost to rent each machine, machine A, machine B, right? Again, the present value of renting A, present value of renting B, we can get it from calculating the present value of A and B, right? Then this is the equivalent annual cost, the equivalent annual rent, right? And we can solve these two equations, get rent A and rent B, right? So in that case, you can see rent A is higher, right? Rent B is lower, right? So in that case, you can see if we consider the effect of inflation, that seems to imply that the equivalent annual cost of renting annual A is higher than the equivalent annual rent of renting machine B, right? The third problem is the timing to replace the older machine, right? So this is also another problem where we think about whether to replace the older machine or not, right? So because if we don't have to replace the older machine right away, right? But use the older machine, using it 1 more year, it's gonna delay the investment in more modern equipment, right? So this is the kind of intervening kind of forces we need to disentangle, right? So let's see this example, right? Suppose we have two kinds of machine. There's one older machine, which is gonna give you $4,000 each of the coming 2 years, right? And then there's a new machine. The cost of the new machine is 15,000, right? And there will be a cash inflow of 8,000 a year for 3 years, right? Now you can see this is the new machine, right? New machine cost 15 in the beginning, 15,000 in the beginning, right? It gives you 8,000 each of the 3 years subsequently, right? The NPV of this new machine is 6.38, right? And then we can also calculate the equivalent annual cash flow as 2.387, right? Again, we think about this as the annuity, right? And the present value equals 6.38. So then you can see the cash flows of the new machine are equivalent to 2.387, right? And then if we compare with the older machine, which can generate cash flow of 4,000, then we should not replace, right? This is a clear implication. Now, suppose the current salvage value is 8,000 and next year's value is 7,000, right? Then we can calculate the net loss if we wait and then sell, right? The net loss is going to be 8,000 times 1.06, right? So if we wait and then we sell, we're going to get net losses equaling 1,480, right? So in that case, we should not replace, right? So this is again trying to see that if we use the equivalent annual cash flow, what's the implication of our decision to replace a machine, replace the older machine or not, right? Finally, we have the problem of excess capacity of the current system, right? So every company, they have existing system, right? Then, so there must be a time where the kind of existing machine reaches a point where there's excessive capacity, right? The managers have to decide whether they want to use the new system or not, right? And that is the load on the existing system increases to the point where the management has to decide whether to whether to stop using the old one and buy a new system, right? So and when we recognize it, then PV of the project might be negative, right? So then we can consider the NPV of replacing or stopping using the current system and replacing it with the new system, right? So this example shows the point. Suppose we have this older system, right? And then the older system is run with excessive capacity, right? Now, if we adopt this new project, right? And the the adoption of the new project means that we have to use the older system, or we need to kind of buy the new system sooner, right? So the effect of adopting this project, which consumes the use of the old system, is to bring the purchase year of the new system forward from year 4 to year 3, right? So, I mean, it increases the depreciation of the old system, right? Basically, that's the idea. And then this new system has the life of 5 years, right? The discount rate is 6%. And then the present value of the cost of buying and operating the new system is going to be 500,000. And we can use the annuity equation to calculate equivalent annual cost, which is this number, right? Now, if we take this new project, that means we have to use the new system from year 4 already, right? If we don't take the new project, the series of expenses will begin year 5, right? So you can see so in that case, the implication is the new project has the additional cost of this number, right? In year 4, right? Because if we take this project, we have to advance the introduction of the new system, which generates the additional cost of this number, right? And what is the present value of this additional cost, which is 94,000, right? And because we consider this additional cost, the NPV of this new project might actually be negative, right? So this is the additional cost we actually have to think about when we take the project, right? Because the adoption of a new project might actually involve kicking in the new system earlier, which increases the additional cost, right? This is the cost associated with adopting this new project, right? Okay, so we finished talking about topic 1, right? Which was really about the present value and its application. And next week, we're gonna talk about the valuing of the bonds. Then of course I'm gonna do a review of today's topic. And this is pretty much the end of this topic.